The empirical formula is the simplest formula. You cannot reduce the subscripts because it's the lowest whole number ratio of atoms in a compound.
The first step to determine the empirical formula is to use the percentages from the problem and pretend that they are grams out of 100. If the amount given is in grams, then you don't have to do this step. Step 2 is to convert the grams to moles via the molar mass. To do this step, you have to take the grams given and divide that by the molar mass of the element, which is found on the periodic table. Diatomics are not used.
For step 3, you need whole number ratios. Usually after finding the moles of the element, it is in decimal form. To get rid of those, divide them by the smallest decimal number that there is. This usually results in whole numbers. Step 4. Step 4 is for if it isn't a whole number. To create the whole number, multiply every number by the smallest whole number possible to get a whole number.
Step 5 is to double check your work. You can find the present composition of one of the elements from the empirical formula that you found, and it should match up with the percent given in the problem.
This is example problem number 1. What is the empirical formula of a compound that contains 69.9% iron and 39.1% oxygen? To complete this problem, you want to use the steps that we talked about earlier. The first step is to use the percents given and change them into grams. So it would be 69.9 grams of iron and 39.1 grams of oxygen. For the second step, you want to convert grams to moles via molar mass. So each substance has 1 mole, and you multiply that by the grams that's given, and then you divide it by the mass number that is given to you by the periodic table. So iron is 69.9 divided by 55.85, and oxygen is 30.1 divided by 16. For step 2, you want to convert grams to moles, so you need to divide 69.9 by 55.85, and you get 1.25 moles of iron. Then you do 30.1 grams divided by 16 grams, and you get 1.88 moles. Step 3 says that you want to divide by the smallest number, so it would be 1.25 divided by 1.25, and 1.88 divided by 1.25. So once you divide by the smallest number, you get 1 mole and you get 1.5. Since we don't have a whole number, you have to multiply by 2. So you multiply this one by 2 and this one by 2. You get 2 moles and you get 3 moles. So the answer would be Fe2O3. We get the 3 from the moles we found and the 2 from the moles we found in iron. For step 5, in finding the percent composition, you use the mass that you have from the periodic table and you times it by the number of moles that you got. So it'd be, for iron, it'd be 55.85 times 2, which is 111.7. And for oxygen, it's 16 times 3 equals 48. Then you add those together and you get 159.7. To find the percent, you then do the element divided by the total that you got. So for oxygen, it'd be 48 divided by 159.7 times 100, which then equals 30.1%, which we started with.
Alright, the answers for practice problem 1 and 2 are